Alright guys, today we're going to be talking to you guys about optimization. So optimization is essentially finding the maximum or minimum solution to a problem. So let me write that down really quickly. The maximum or minimum solution to a problem. So now I'm going to go through a couple examples with you guys of some problems you might encounter while doing optimization. So the first problem reads, find two positive numbers satisfying the given requirements. The product is 1200 and the sum of the first plus 3 times the second is a minimum. So when doing these problems, I like to write down what I know. So what I know is that the product of these two numbers is 1200. So I'm just going to say that x times y equals 1200. I also know that the sum of the first one, being x, plus 3 times the second one is a minimum. So I'm going to assign the minimum a letter, M. Let's do M. So now the next step for this is to solve for either x or y given this equation here, which is called our constraint. So I'm going to solve for x. So x is equal to 1200 over y. So now what I can do is I can plug this in over here. So now the equation becomes 1200 y plus 3y equals m. So now, in order to find the two numbers that fit these requirements, I need to find the critical values. So to do that, I'm going to apply the derivative right here to this equation. And when I do that, I need to use the quotient rule for this part. And that's going to give me 0 times y, which is cancels, minus the derivative of the second, which is just 1 times 1200 over the bottom squared. And then the derivative of 3y is just 3. So now I know that m prime is equal to 1200, negative 1200 over y squared plus 3. So now to find the critical values, I need to set this equal to 0. And once I do that, it should look something like this. 0 equals negative 1200 y squared plus 3. So I'm going to move the 3 over, and I'm going to get that negative 3 equals negative 1200 over y squared. Now I'm going to solve for y, and I'm going to get that y squared equals 400. And that y itself is equal to 20. So now that I've figured this out, I need to go back to the constraint equation over here, which is this one right here. And I'm going to plug in the y equals 20, and I'm going to get that x times 20 equals 1200. So when I divide by 20, I get that x equals 60. So now to answer the question, the two positive numbers that satisfy these requirements are 20 and 60. Let's do another question. So this question says, find the length and width of a rectangle that has the given perimeter and a maximum area. So again, let's write down what we know. Well, we know that the equation for the perimeter is perimeter equals 2 times the length plus 2 times the width. And we know the perimeter, so we can write 164 equals 2L plus 2W. And the formula for the area of a rectangle is area is equal to length times width. So like before, we need to solve for one of the letters. I'm going to solve for L. So I'm going to move 2W over and then divide everything by 2, which will give me that L is equal to 164 minus 2W over 2. My next step is to plug in this right here. So when I do that, I'm going to get that A is equal to W times 164 minus 2W over 2, which will simplify to A equals 164W minus 2W squared over 2. And I can simplify this further with one final step. That gives me that the area is equal to 82W minus W squared. So now I need to apply the derivative to find the critical values as I did before. So A prime is going to give me 82 minus 2W. Now my next step is to solve for the 0. So I'm going to make it equal to 0. And I'm going to solve for W. So move the 82 over and then divide by negative 2. And I get that W is equal to 41. So now what I need to do is I need to plug this right here into this equation to find my L. So I'm going to do that right now, and I'm going to get that 164 is equal to 2 times L plus 2 times 41. And this should be equal to, or this is equal to 164 plus 2L, or equals 2L plus 82. So now I'm going to move the 82 over, and I'm going to get that 2L equals 82. And I'm going to divide by 2 to get that L is equal to 41. So now to answer my question, the values that give you the perimeter of 164 and a maximum area are 41 and 41. So let's do one more question. Let's go down. Okay, so this question says, find the point on the graph of the function that is closest to the given point 2, 1/2. And they give us the function y equals x squared. So for this question, we need to use the distance formula, which I'm sure most of you know, which is the distance is equal to the square root of the change in x squared plus the change in y squared. So now I have my function and I have my point. So I'm going to put my point here and I'm going to label it 2, 1/2. Just pretend that it's a 2, 1/2. And I'm going to draw a line here. And this line is D. So I need to find out what the change here is in my x and in my y. So here, the imaginary point that we're trying to find has an x, y. So that difference from this point would be x minus 2. So this would be x minus 2 squared. And then the change in the y would be equal to y minus 1/2 from here. So we'll get y minus 1/2 squared. And of course we have the square root over everything. Now, as we've done before, we need to solve for one of the variables so that we can solve for one variable, because we can't solve for something that has two variables in the equation. So I know from this part right here that y is equal to x squared. So I'm going to change this y over here to y squared, and I'm going to rewrite everything. So we have that the square root of x minus 2 squared plus x squared minus 1/2 squared is equal to the distance. So now what I'm going to do is I'm going to FOIL this out in here so that it makes it easier to apply the derivative when finding our critical values. So really quickly, I'm going to go to the side here and I'm going to work this out. So I get x minus 2 times x minus 2 gives me x times x is x squared minus 2x minus 2x again plus 4, which then gives me x squared minus 4x plus 4. And now I'm going to do this part. So this part gives me x squared minus 1/2 times x squared minus 1/2. So I'm going to do this again. I'm going to FOIL the same way. Then I get x to the 4th minus x squared over 2 minus x squared over 2 and plus 1/2. Or sorry, not 1/2. 1/4. I apologize. So now when I do this, I'm going to get that x to the fourth minus x squared, because 2 over 2 cancels later on, plus 1/2 is this one when foiled. So now I'm going to combine like, well, first I'm going to rewrite it, and then I'm going to combine like terms. Oops. Okay. So I'm going to rewrite this as the distance is equal to x squared minus 4x plus 4 plus x to the fourth minus x squared plus 1/4. So now after this, my next step is going to be to combine like terms. And I'm going to get that these two cancel, and the rest should be x to the fourth minus 4x plus 4 plus 1 over 4, which I can combine over here on the side really quickly. 4 over 1 times 4 over 4 gives me 16 over 4, plus 1 over 4 gives me 17 over 4. So I'm going to change this really quickly to 17 over 4. Okay. So now that we've simplified everything inside the radical, we can apply the derivative to find our critical values. So before I apply the derivative, I'm going to write this in terms of exponents. So this is equivalent to x to the fourth minus 4x plus 17 over 4, all to the 1/2 power. So now I'm going to apply the chain rule to this. And I'm going to get that d prime is equal to 1/2 times x to the fourth minus 4x, this plus 17 over 4, subtract 1 from the exponent, and I get negative 1/2, times the derivative of the inside, which gives me 4x to the third minus 4. And then that is what d prime is. But this looks kind of messy, so we're going to transform it a little bit to make it look easier, or make it look nicer. So this is equivalent to 4x cubed minus 4 over 2 times x to the fourth minus 4x plus 17 over 4 to the 1/2 power. So now that we have our derivative, we need to solve for the critical values. So I'm going to make this equal to 0, and now I'm going to solve for x. So I'm going to multiply everything on the bottom over, and it's going to cancel with this 0. So I can just take this out. So now I'm left with 4x to the third power minus 4 is equal to 0. So I'm going to rewrite this so that no one gets confused. And now I'm going to solve for x. So I'm going to move this 4 over, and I'm going to get that 4x cubed is equal to 4. Then I'm going to move the 4 over, and I get that x cubed is equal to 1, and the cube root of that is just 1. So now I know that x equals 1 for this point. So now I'm going to go back to the very, very beginning. And now that I know that x equals 1, I simply have to go back to the original equation, which is this one right here. And I need to plug in a 1 for the x. And I'm going to get, when I do that, that y is equal to 1. So now I know that the point closest to the point that they gave us is 1, 1. And this would be the final answer. And that's it.